Welcome to Easy Math. This is the last lesson on the topic of further logarithms as we tie together all the concepts in the topic through logarithmic equations and expressions. And so let's get to it as we tackle some questions. Before us is a question given and appears on your screen there, 5 raised to power x, then 5 raised to power x minus 1 is equal to 10. So we're supposed to solve for x here. We're going to use our knowledge of indices to operate as follows. First of all, 5 is a common base, and these two terms are multiplied together, and therefore we are supposed to add the base, the indices, the x and x minus 1, and therefore it's going to appear something like this. And simplifying further, you're going to get 5 raised to power 2x minus 1 is equal to 10. Now, moving further, we're going to have the expression change to what you have on your screen there. Someone is wondering how we arrived at this. If you take log to base 10 on both sides, you're going to get log of 5 raised to power 2x minus 1 is equal to log of 10 to base 10. And therefore, if you can just change this using the fact that 2x minus 1 is a power of 5, so you bring it before the log of 5 and divide both sides of the equation by log to base 10 of 5, you're going to get 2x minus 1 remaining before the equal sign, and after the equal sign you're going to have only 10 log of 10 divided by log of 5. This is tackled in the previous lesson, so you can check that video, the one posted just before this. Now you're going to divide both sides by you're going to divide simplify the expression after the equal sign, and you get 2x minus 1 is equal to 1.431, and therefore taking 1 on the other side you get this sort of a thing, and x will be 1.2155, and that happens to be the answer for the value of x. Again, we told express y in terms of x in the equation, and the equation is appearing on the screen there. What do? First of all, we're going to combine the terms before the equal sign using the first law we wrote about the law of logarithms. And so you're going to have it as log to base 6 of x, this x here, times y cubed that way is equal to 1. And so it simplifies to this. And now we're going to express this in its in-text notation. So this being the base, this being the logarithm, which now is also the power or index, we could actually write it as 6 raised to power 1 is this number here. You can always check the first video I posted. It had this sort of definition where we change notations from logarithm notation to index notation and vice versa, and therefore xy cubed is equal to 6 raised to power 1. Now, simplifying this, just this one here, and therefore we divide both sides by x, we get y cubed is equal to 6 all over x, and therefore y is the third root of 6 over x, or if you like, the cube root of 6 all over x, and that is the answer for the expression y in terms of x in that given equation there. We have another question told this one here, log of x to base 2 plus log of 2 to base x is equal to 2. Find the value of x. Notice the interchange of the basis is 2 and x, and the numbers are x and 2 respectively. So what do? First thing is we're going to let 2 to base x be, say, k, and you put or write that in its index notation. That is x raised to power k is equals to 2. Again, take log to base 2 on both sides of this equation, x raised to power k is equals to 2, and so you're going to get log of x raised to power k of 2 to base 2 is equals to log of 2 to base 2, and log of 2 to base 2 is 1, and therefore this equation can actually simplify to this if you brought the k down here, so that you have k log of x to base 2, divide both sides by log of x to base 2, and so you get k is actually this one here. But what was k? K was log of 2 to base x. And having gotten that, we have an observation to say here. So long as whenever we are told log of, say, b to base a, it is normally the same as 1 all over log of a to base b. This observation is very necessary, and is very much, let's say, related to observation I post that was in the, I think the 2 videos before this video here. We had an observation which had similarity like this, where we said log of p to base q is m as log of p divided by log of q. And again, look at this one here. Log of b to base a is m as 1 over log of a to base b. notice the interchange of the number and the base in the expression before the equal sign and the one below the division line, and therefore this is true. Having thus said, we're going to say therefore that log of x to base 2, that's what we had here, plus 1 over itself, that's what we got for the value of k, is equals to 2. And just to clarify that, what has changed? This term is still this term here, so nothing has changed there. But we have simplified that log of 2 to base x, which was k, can be written as 1 all over log of x to base 2, which is what we have here. It's equals to, this 2 is just that 2 there. And so now we progress as follows. We can let x, log of x to base 2 be, say, m, and therefore now we have m plus reciprocal of m is equals to 2. That becomes a quadratic equation, which is simplified to get m squared minus 2m plus 1 is equals to 0. So for m, you get m is 1. This looks like a perfect square. So if m is 1, therefore, we're going to say log of x to base 2 is 1. Since what was m? M was log of x to base 2. Now we're saying it's 1, and there it is. Now, the value of x, we're going to put 2 raised to power 1 is equals to x, and therefore x is 2. And that is simply the answer, what that we desired. And if you replace here, you're going to get the answer is the same, because log of 2 to base 2 is 1, log of 2 to base 2 is 1, 1 plus 1 is 2, and therefore that's actually true. Moving on, we have a question there. Told solve the simultaneous equations below, and you told that one there, and another one, that one there. So what do we do? The first thing, for the log of y to base x is equals to 2, we can express it as its index notation, where we have x squared is equals to y this particular way. Therefore, x squared substitutes y in the second equation. Where we have y in the second equation, we can put x squared. And that means for x, y is equals to 8, the y is replaced with x squared. And therefore, we have this sort of a thing, which according to the law of indices, therefore, this x and this x being the same base, this being raised to power 1, sorry, they are multiplied together, we just add the powers. Yes, this raised to power 1, this raised to power 2, so therefore we just have x raised to power 1 plus 2, which is x raised to power 3. That's what we have there. Taking that root of both sides, get the value of x is 2. And that is the value for x. But what is y? Y is 2x squared, because we said y is x squared. Sorry, y here is 2 squared because y is x squared, because x is 2. Therefore, y is simply 4. And that's the value of y. If you put the values for x and y to be 2 and 4 respectively, you're going to get your answers as 8 and as 2 respectively. Another question told solve the following. You told log of x is equals to 4 log 2. Now, what you do there is we're going to move backwards with this, let me call it expression after the equal sign. 4 log 2 can be written as 2 log of 2 raised to power 4, and therefore at that point we can cancel the logs. See, the logs appear. The log to base 10, the base 10 is not indicated, and we said at some point that when the base is not indicated, it means it's base 10. Therefore, since we have the same base, we can ignore it. So we have just x is the same as 2 raised to power 4. And therefore, what is x? It is 16, and that's simply the answer. Another question you told, that one there on your screen, and so we are supposed to solve a while. What do we do? Please notice that this term is just written simply like this, but the 4 can be written as 4 log of 3 to base 3 this way, and the other one remains as it is. And now we combine them, the terms before, and continue like this. The 4 can be brought to be a power of 3 as it's written here, so that instead of having 4 log 3 to base 3, we have log of 3 raised to power 4 of base 3 to base 3. And combining them using, I think the second law that we wrote for indices, we're going to have log to base 3 of y divided by 3 raised to power 4 is equals to log of 3 raised to power 5. You can cancel the log to base 3 on both sides, and so we're left with y divided by 3 raised to power 4 is 5, and therefore y is 5 times 3 raised to power 4. The answer is 405, and that is the answer there. Another question you given on your screen there, Again, we progress as indicated here. We're going to have the equation as it appears on the screen there. What has happened there is we have just copied this as it is, so that we continue to work on it. And therefore, the first part here, 2 raised to the power 2 is just 4. And therefore, this part here, that's the first term, can be written as 4 log of 2 to base 2. The reason is log of 2 to base 2 is just 1, and therefore this is just, all of it is 4. I've just introduced log to base 2 so that the question will be workable. This other term here is just as it was here. This other term here is just as it was here. 9 can be written as 9 log of 2 to base 2, and therefore that is what we have there. The first term here, the term after the equal sign, are changed by just introducing log of 2 to base 2. Now progressing on, we have this 2 raised to the power this 4, it becomes 2 raised to the power 4 like that. This second term happens to remain like this. This other term here becomes 2 raised to the power 5 like that there, and this becomes 2 raised to the power 9 like that on there. Now combine the terms for the equal sign using the laws of indices, or you can just work it out that way, this particular way. Take log to base 2, and then you have 2 raised to the power 4 times x squared times 2 raised to the power 5 is equals to that on there. And you can cancel the logs. Forget about the logs because they are just the same. Log to base 2 on both sides before and after the equal sign. Using indices, simplify this. You're going to get x squared divided both sides by 2 raised to the power 4 and 2 raised to the power 5. You get this sort of a thing. Now these are 2 raised to the power 9 divided by 2 raised to the power 4, 2 raised to the power 5 should give you 1. And therefore x is just 1. And that is the answer. If you put x to be 1 here, the answer is going to be 9. And you can always check that out. Now, having that said, I've come to the end of my presentation about laws of logarithms, the further logarithmic equations, and even the definition of logarithm, and therefore the end of all that we would have to tackle about further logarithms. Check out for more videos. Coming next will be on the topic of commercial arithmetic 2. So check that out. And as always, please like, share, subscribe. I'll always appreciate. Thank you.